Hello, and welcome to Let's Meet the Virologists, a podcast about the people behind today's virology headlines. People just like you working to understand viruses and how they affect you. During the COVID-19 pandemic, we are talking with postdoctoral researchers involved in coronavirus and COVID-19 related research so that you can learn who they are and what they do. I am Larissa Thackeray, and I am hosting this podcast from America's Heartland in St. Louis, Missouri. Only a couple drugs are currently being used to treat COVID-19. And although others are under investigation, there is a clear need for broadly acting antiviral drugs. On September 25th, 2020, we talked with Dr. EJs Perng, a postdoc in the LMtV lab at Washington University School of Medicine, who has been working to identify novel antiviral therapies. EJ received his bachelor's in zoology and master's in microbiology and immunology from the National Taiwan University in Taiwan. He obtained his PhD in molecular microbiology and microbial pathogenesis at WashU, studying human cytomegalovirus. He then joined the LMtV lab to characterize the function of ISG15, a molecule that he became fascinated with while working on the papain-like protease of SARS-CoV-1 after the 2003 SARS epidemic.
Hi, EJ. Happy to have you with us today. Why don't you tell us a little bit about yourself? How did you become interested in virology research?
Thank you for having me. I read a lot of evolution biology book from Stephen Gould in high school, and that made me really interested about biology. So I was from Taiwan, and during the college I majored in zoology, and then but once I jumped into college, I was attracted by molecular biology really fast, and that was I think the 2000. So that was the genome project just start. So I part-time in the institute called the National Health Research Institute, and then it's really similar to NIH here. And my major project was actually on cancer, because I think cancer is really fascinating how the genome can change over times. And then during 2003, that was the SARS pandemic, and then so in Taiwan, we were hit really bad. And then that was that. So I don't know how many people still remember the SARS-CoV-1. So it was happening in the winter time of 2003. And then the virus was spread really quick. And then in Taiwan, because we have some political issue, we didn't got any notice and support from WHO. So when we saw the cases show up, it's jumped up really quickly. And then, so basically we have no idea how to handle things. So the only thing we can do is to shut down hospital, because there is a couple hospital outbreak, and all of the non-essential surgery was canceled. And my father was having a liver tumor at the time. So he missed the chance to get therapy. So later on he died. So that's, I think it's kind of a sad story to drive me to want to study more about virology.
Could you describe a little bit your path? So how did you get to graduate school, your postdoc?
Yeah, so during the SARS-1 pandemic, that's my senior year. So after that, I went to get my master's degree, and I choose to work on SARS-CoV-1. And SARS-CoV-1, the virus is RNA virus. So after it get into the cell, they will make a really long polyprotein. So virus need a protease to cut them into different chunks, and then the cutted peptide can wrap into functional protein. So the virus have actually two proteases. One is called the 3CL protease. That's probably more well known. And the other one is called the papain-like protease. And during my master's degree, I tried to find where is the cutting site of the papain-like protease cutting on SARS-CoV-1 genome. So we try to set up the high throughput screening assay. So that's basically the project of my master's degree thesis. At the time that when I did some bioinformatics research, I found papain-like protease actually have another two functions. So one function is it can remove ubiquitin from the modified protein. And the other one is that this protease can remove IgG15 from the conjugation protein. So I was wondering that, so what is IgG15? So when I read up my project, I think that's the in Taiwan, we need to went to 2 years mandatory military service. So after I graduated from my master's degree and before I went back to military, I talked to my advisor, say that I want to take a look what's going on and what is IEG 15. So I spent a whole summer work there, and after military service, and then I need to apply graduate school. So I still want to work on the virus, but I want to working on how virus interact with host. So I search for different medical school in United States, and then I'm also a big Kano fans, and in Taiwan we play baseball. So in high school, in our newspaper phone line, we will have a small column to show that if today is end of the season, how much home run McGuire will have or Sammy Sosa will have. So since that time, I already become a Kano fan. So I think, okay, why not I just apply school in St. Louis? So I opened the Google Map. That's still a very, very ordinary version. And I try to see if there is any school around. So I saw WashU, and I know I have a classmates alumni. He was also in WashU, so I know should be a good school. So I applied here, and luckily I got in. And then I started searching for the virus that's involved in either the latency or the host viral interaction. So in the end, I joined the Dongyu lab. Dr. Yu, he was in WashU at the time, and he was studied the human cytomegalovirus. So my thesis project was set up a reverse genetics system. So the idea is that the human cytomegalovirus is a huge virus, and they have over 250 genes at the time. Right now, I think people believe they have more. So we want to know what kind of genes is essential for the infection. So the best way to knock out the gene one by one. So that's the purpose we want to have the screening. And then later on, I choose one gene is actually involved in viral gene transcription during the late stage of viral infection. And it's kind of very interesting project because the virus, they don't have their own RNA polymerase. They actually use a host one. So that gave me a chance to look how virus hijack host transcription machinery. And then we even got a chance to repurpose a cancer drug to block CMV infection. So I think that's really interesting job. And then, but unfortunately, in my last year in graduate school, Dr. Yu, he decided to move to industry. He went to Novartis. So I still have 1 year to go. So I brought my project and Debbie, she was my committee chair. She was really nice to adopt me. So I brought my project and to her lab. And when I work on that project, I got a chance to look at the mass spec result from lab. During the time, they try to figure out what's the protein partner of IEG 15. And when I saw the list, I think, okay, this is something I really want to work on because there's a lot of really interesting projects. So I jump in and then start to working on IEG 15 again. So it's kind of a long loop that in the end, I went back to IEG 15. And then, so IEG 15 is actually a gene that they will be robust induced during type 1 interferon induction. So we know type 1 interferon is really important for viral infection. So during viral infection, type 1 interferon turn on and they will induce a lot of gene expression we call the ISG. And IEG 15 is one of the most robust induced genes. So I think during viral infection, it's kind of really bad time for the cell. If they want to invest a lot of energy to produce IEG 15, there got to be a reason. Otherwise, evolution will not favor it. So during my postdoc years, we found that IEG 15 is play another really important role to modulate host homeostasis. So that's a project ongoing. We are going to submit our finding really soon.
Oh, that's exciting. So I guess when you look back on sort of the research that you've done so far, what was the most exciting sort of the eureka moment that you've had so far?
I think there are two. One is when I try to find a CMV antiviral, and then we use a GAP virus to infect the cell. So every day when I check how the cell look like, I will open a GAP scope, and then I I would just look at the GFP signal. And then I still remember that morning that when I turned it on, and then the 96 well plate was dark, I thought, well, is the GFP scope broke or something like that? And when I turn on the light, all the cells are there. And that's the moment that is kind of amazing. And the other Eureka moment is recently when we're working on the IEG15 in host homeostasis. We crossed the 15 knockout mice to the other strain of mice lacking the critical molecule we are studying on. And then after the viral infection, I weigh the mice every 2 days, 3 days. It's kind of nervous moment when you put off the gun and walk into the facility, and then the mice still there. You didn't got any call from DCM, you didn't got any tag. And that's the most exciting moment I have at the moment.
And sort of conversely, what is the most difficult thing you've had to overcome so far as a scientist, and how did you overcome it?
The most challenging part to me in my career is probably when Dr. Yu decided to move. I'm kind of wondering where I should go. So I talked to a lot of people, a lot of PIs, and try to seek in a mentor. And I think that's the most difficult part for me. But if I look back, I think that's also the moment I become more independent and also really know what I really want in my career.
I guess if you had a chance to ask your older self, so someone later on in life, you at 60, 70, or getting close to retirement, one question, what would it be? What would you want to know?
Every time when I have any challenge when I do experiment or something like that, I always tell me that try to do something I will not regret when I'm getting old. So I think if I got a chance, I will ask an old EJ that did I do everything I will not regret now? And then how does he feel at that moment when he's 60s, 70s?
To follow up on that, how do you make sure that you're doing what you want to do?
There are some questions I really have no idea. Then I need to seek help from mentor, from advisor. And there are some moments, I guess you probably also feel that we actually already know the answer, but we are not there to do so. Or we just think there's too much and that would be a burden. To be honest, I have no good answer for that. Try to do my best.
Can you describe how you started working on COVID-19?
So when I noticed the COVID pandemic, that's actually the first week of 2020. That's in Taiwan, they respond really, really fast, really early because of 2003. I think for every Taiwanese people, when they see any coronavirus, either MERS or SARS-1, SARS-2, people getting along. So I start to take a look what's going on. And then I start to trace the number. And I still remember I teach Sunday school in my church. I try to bring some science into church. And then the first time we count how many cases, the COVID cases in the class, I think that's end of January. And around the time, we probably have 50 mortality around the world. And I start to feel this is not something right. And I continue to talk to Debbie. And I think in WashU during the time, we respond really early. And a lot of PIs start to jump in. But during the time, we think our expertise in the lab is majorly on pathogenesis. So that's probably not the first responding. What we need is reagents and repurposing drugs. That's not our expertise. We decide to hold for a while. And then end of February, the school started to lock down. And then I got a call from Debbie, I think the first day or the second day of lockdown. And she told me that we have a collaborator in UT Austin, the John Hubris lab. And they also working on IEG15. And they do some literature research. And they found that there is a compound is called the 6TG. They were reported to inhibit SARS-CoV-1 PO-Pro. So they are interested to see whether this drug can also repurpose to SARS-CoV-2. But they have no facility to do the viral infection. So Debbie knows that I work on protein-like protease before. So she asked me, do I want to do this? I said, yeah. And then, so that's the beginning. We started working on COVID.
Can you tell us a little bit more detail about the work that you have been doing?
So right now we basically have two parts. One part is the repurposing drug part. So we have this compound called 6-TG, and we know this compound, they can block the SARS-CoV-1 viral replication, but not the MERS papain-like protease. So the first thing we need to make sure this drug indeed inhibit viral replication. And during the time we don't have enough capacity to do COVID-2, you know that there's limited PPE and also the facility. So we collab with Yi-Chieh lab, and Yi-Chieh and his postdoc, they are excellent. They help to do the infection and then harvest the sample, and we do the analysis all together. And then we found out this drug actually worked really good in viral cells, but viral cell lack the some host pathway like interferon response. So we use another cell line called CLU3 cells, and we try to see whether we see similar things. So fortunately, we see very similar things. So we decide to move on to characterize the function of the how 6-TG block PL-PUR. And so that's one part, the drug repurposing. So hopefully we can have more mechanism to see, because as we mentioned, PL-PUR have three functions: protease, deisogenase, and deubiquitinase. So which one play more role during our infection, and whether that's a real drug target, that's something we need to characterize in the future. So for the second part of the research in our lab, that we try to figure out whether IgG15 is involved in COVID-2 pathogenesis. The reason we want to focus on IgG15 is because the COVID, they encode papain-like protease, so they will actively create a lot of free-form IgG15 in the infected cell. And based on our research, we found free-form IgG15 play a critical role to moderate the immune response during viral infection. So that's something we try to figure out. But we are still setting up the cell system and also the mouse system. As people know that it's really, in the beginning, we will struggle to find the right cell that COVID-2 can infect, and also to try to find or try to match mouse adaptive strain virus, so we can use the genetic knockout mice to do the research. So that's the part ongoing.
Can you talk or tell us a little bit about some of the reagents that you've had to acquire in order to do this work?
Yeah, I think that's a long thank you list. So I'm really fascinated that during the COVID pandemic, we have a lot of collaborations throughout the country. And I think the first for the virus, we got the virus from Diamond Lab. They make the virus so we can amplify from in our facility. And in the beginning, as we mentioned, we cannot do the COVID-2 infection work by ourselves. So we need to work with Yi-Chieh lab, and they have really good hand and did experiment really precise to do the first step infection and then harvest lysate, and we can get them move on. And recently, the mouse adaptive strain was created by Rob Barrick lab in North Carolina, and we just passed all of the MTA, and we hope to use this virus to validate whether IgG15 really plays some role.
Moving more to the personal stuff, how has the COVID-19 pandemic affected you as an individual?
It infects a lot. As I mentioned, that I noticed the outbreak pretty early, and then, but I really regret that I didn't speak loud enough to warn people that we should have more measure like wear a mask, or to notify more people that this is something seriously. I think when people start to realize the virus in the States, since it was a little bit out of control. So that's I think one biggest lesson to me, that being the researcher, we spend a lot of time in the lab, try to understand the most latest technology. But on the other hand, maybe there is some time we really need to stand out and then try to convince people how to do the right thing at the right moment.
We had discussed sort of offline some of the things that you've been doing. So these like concerts that you guys have been doing. Do you want to talk a little bit about that?
I think we have the lockdown until end of May, and St. Louis start to partially reopen in June. And before that, I think St. Louis did a really good job. We had a really low number. I think a lot of newspaper, they kind of say we are doing again like 1918. In 1918, St. Louis did a really good job in contrast to other cities like Philadelphia. But starting in June, we see the cases spike. and the number go up so quickly. So I start to wonder that what's going on, whether we should have some way to convincing people to keep social distancing, to wear the mask. And my wife and me, we have a close friend. She's the musician in St. Louis Symphony. She played clarinet. So during the time they have, she and her friends play some chamber music in the neighborhood. And once she told me she want to have the chance to play music, salute to the scientists. And I think that why not we have the scientists also talk about the importance to wear a mask, to keep social distancing. And then we also find one of our friends, she graduated WashU and right now have a big company. He is ready to provide mask and also provide audio system. So certainly we have the concert series. I think when I do this, the 2003 experiment continue to remind me that what's the right thing to do. And I feel this is the right thing to do. So I try to push. But as you can imagine that in some area, people, they are willing to wear a mask, we can get good response. But in some area, people are more reluctant. But that's also the time that I start to realize everybody have their own story. Nobody want to be the bad boy from the beginning. So I try to find some chance to talk to them, to know that what's the reason they didn't want to wear it. And of course, during the concert, we can ask everybody to have mask. So we make sure everybody is safe. But that's the time I start to learn a lot of reason why people didn't want to wear it. And in the beginning of pandemic, everybody was scared. So everybody are willing to do everything we want them to do. But I think right now, particularly for parents, we can start to feel kids are tired, parents are tired, and everybody looking to go back to a normal life. And as a scientist, we can working hard, but all the therapeutics, vaccine have their own timeline. So how we can strike a balance during the time, I think that's the biggest part I learned from the whole concert series.
So I guess to follow up on that, sort of as a virologist, how do you personally make decisions about how to keep yourself, your family, your community safe?
I think during the early of pandemic, I try to talk to all my neighbors in the neighborhood, try to convincing them that to wear a mask and what's going on right now. And then for my kids, my wife is also a scientist, so she knows that how the virus or the virology stuff. So it's kind of easy for us to educate our kids. And during the concert series, I brought them to every concert, so they have the chance to see what's opinion that I have and why we want to do these kind of things.
So when you're evaluating risk, how do you decide whether it's okay to go to a grocery store or to go to a gym or to do outdoor concerts? How do you make decisions about that?
During the earlier pandemic, we try to avoid all of them. And then I try to do all the grocery shopping by myself. And then later on, we try to continue to follow all of the literature and like some study about the spread of droplet, and then the effectiveness of mask or some contact tracing research. And I try to translate into the kind of layman language to let my kids know that why we want to do this, why we don't want to do this. And so that's the way I try to do. But to be honest, in the beginning, we were really, really scared about this.
And what do you think now? So you've sort of mentioned that your kids they're thinking about putting your kids back to school.
Yeah, I believe the risk is definitely high. And then, but the problem is that right now is a moment that we need to strike a balance between kids' mental health and also the real risk to get the viral infection. And I think during the concert series, one biggest lesson I learned is that a lot of people, they don't want to wear masks were because they lack of motivation. But if they try to follow all the procedures and stay at home, some people, they even got furlough at home and they are worried about bills. But every day when I open news, open internet, the case number is still high. So for them, it's really hard to convince them to continue to do this for months. So I think if right now we send the kids back, they definitely will have some chance they might have some outbreak. But there's also a chance we can put all the responsibility back to the parents, back to the kids. It's now their responsibility to protect their teacher, to protect their parents, to protect their grandpa and grandma. I don't know whether this will be a really dangerous move, but I think in terms of motivation, maybe parents will have more strong motivation on that.
Great. So I guess, everyone's been working a lot. Everyone's been stressed out. Is there something that you've been doing new sort of in your free time? Any new hobbies that you picked up during the pandemic?
I'm a big Cardinals fan. But during the earlier pandemic, there was no game here. So I have no chance to watch anything. And I work a lot. So my wife, she suffers. She needs to take care of kids at home. And the only thing I can try to make sure when I got home, I try to spend more time with kids. And we were thinking about what kind of thing we can do. So when I was 5th grade, my favorite hobby was watching birds. So I was thinking, okay, we purchased 2 binoculars. And I even called Dr. John Atkinson to ask him where is the good place to watch birds. And he told me that, well, right now is a good timing. That was late March, early April. So that was a migration time. And he told me that just go to the state park to watch birds. And then I said, okay. And the following day, state announced they closed all the state park. So we have nowhere to go. And I start to work on COVID, so I cannot be close to birds. So so the only bird watch we can do is just take binocular and watch in our backyard. But it's kind of cool that we never realized we can watch more than 50 different kinds of birds simply in the backyard. That was amazing. And we also use that binocular to watch there is a comet called the New Weiss in July. And we have a lot of work. The family will take a lot of work outside. We try to explore different lakes. And then I think, on the other hand, I think that's really good memory for me and for my kids. I believe 20 years later, 30 years later, everybody will remember what they did during this pandemic time.
So I guess we're winding down. Any last messages for our listeners? Any thoughts about the future of the COVID-19 pandemic?
Yeah, I think I really like to quote RBG's what she say that fight for the thing that you care about, but do it in a way that will lead others to join you. I feel that during this time, people are angry and people have a lot of stress, but by the end of the day, we should work together. And then we can have different opinion, but we should not hate each other. So if there is any way we can work together, just try it. I feel blessed that I'm working in the virology community right now, people working with each other and doing things in the unbelievable speed to get things done. I think it's a really bad moment, but it's also a really good moment. I just hope everybody can hang in there and we will be there.
All right. Well, thanks for talking to us.
Thank you for having me.
EJ's previous experiences with SARS coronavirus at home and in the lab prompted his current research efforts to find new antiviral drugs for SARS-CoV-2, but also informed his desire to participate in community outreach efforts discussing public health measures to reduce SARS-CoV-2 exposure. This has been Let's Meet the Virologists, a podcast about people who study viruses. This is your host, Larissa Thackeray, and thanks for listening. You can find us on Google, Apple, and Amazon Music podcasts or at lmtv.podbean.com. If you are a virologist interested in sharing who you are and what you do, please contact us at letusmeetthevirologists@gmail.com.